Hi folks, Jeff here. Time for another video. Today's video is on the tire pressure monitoring system of a car, TPMS. Specifically, a 2014 Toyota, although it could be any car. I'm going to explain how the tire pressure monitoring system works and how you can fix it. So if, when you start your car, there is a flashing light that looks like the cutaway of a tire, what that means is that the computer in the car cannot communicate with the sensors in the wheels. This particular car is, a Toyota with a single light warning system, which means if it cannot communicate with any of the tires, it will start the light flashing. If this were a car where all four tires were displayed in a picture of the car where it showed each of the sensors and the pressures, it would still display the other tires that it could communicate with. In this case, because it's only a single, it flashes. This does not necessarily mean that your tires are low. What it means is that the computer cannot determine if your tires are low. So your tires could be perfectly fine. Once you start driving, the light will turn solid. And my guess on that is because a flashing yellow light on your dashboard would be distracting. And there it is, went solid. And so what Toyota does is turns it solid after a while, and this way it's no longer a distraction, but you still know that that there is a problem. Also, I don't know if you can see down there in the corner, but it is 25 degrees outside, which is the high for today. And so I am going to remove the wheel and bring it inside where it is warm and continue the video. Before we start taking wheels off, it would be good to know which sensor is actually bad. So I have here the TPMS sensor tool. This is from Autel, the TS508. They didn't sponsor me. I didn't get this for free. I've used it now for a little while and it seems to be pretty good. It's not $1,000. It's like $200 and some dollars. But the price of 4 sensors and this tool was less than having the 4 sensors replaced. And I have multiple cars and relatives. Plus I wanted to do this, so I bought it. In any case, let's see how you can tell if the sensor is bad. So this tire has the OEM sensor in it, and we'll go to quick mode. Yes. It's a Toyota. Yes. It's a Camry. That's true. Now here is where you have to be careful. It's important to make the correct selection. They are not interchangeable. So this car is a little more difficult than some. Obviously, if you have a car that's a 2009, you're not going to pick the first choice, 2020 to 2022. But if you look in the center, you'll see that there are 2 choices that include a 2014. One is with a manufacture date of 9/2014 to 12/22, and then 10/2011 to 12/2019. So they're overlapping. So in this case, it turns out the car was made in 01 of 2014. In case you don't know where that is, if you go into the driver's side door and you look at the plate that's in there, it will tell you 1/2014. And so that precludes the other selection. Now, if you choose the wrong choice, the sensor will not read. It's like the sensor's talking French and the tool is looking for English, and they will not talk. Same thing with the computer. So the computer is matched with a certain protocol to the sensor. The Autel sensors that you replace it with, they speak all the languages. So this tool will always recognize and tell you what the sensor says, but that does not necessarily mean that the sensor can talk to the car. So you could put a sensor in, read it with this tool, it says everything is great, and yet the car does not recognize the sensor. So I can show you that if we take the incorrect setting, so we take the one from 9/2014 to 12/2022, and we say yes, and then we say scan a single sensor, and we push the yes button, and then we push the trigger button. It will sit here all day and will not read. So you would think, oh, this is a bad sensor. It is not a bad sensor. It's speaking the wrong protocol. So I'm going to hit cancel, because if you've used this for a little bit, you'll know that when it reads in an instant. There is no wait. So we'll say no. We'll go back again. This time we'll choose the proper, correct sensor. Say yes. Scan a single sensor. Yes. And trigger. Instantly found the sensor. Everything is great. So why does this matter? It matters because when you change the sensor to the new sensor, you have to program it with the proper protocol. If you do that, everything is great. If you don't, the sensor's fine, it's speaking, but it will not talk to the car. So we're going to go around and do this for all the tires. 2 of the tires on this car, I've done this before, I know will not scan. They just sit there forever scanning, even though it's the proper protocol. And 2 of them work. So the ones that work clued me into the proper setting, because obviously it works, and that's the setting to use. So as long as you keep that in mind when you put the new sensors in, they should work. Back down in the shop where it's nice and warm, here is a TPMS sensor. This is the original one off of a car. Why did this happen? Why did the sensor stop working? And the answer is simple. The battery has died, most likely. You can see right here, there is a coin cell battery inside there. It only lasts for so long, 5, 7, 8, 10 years, maybe, but usually a little more than 5. And then the battery goes dead and the transmitter stops transmitting. Could the electronics in here be bad? I suppose so. Either way, you're still going to need a new one. The other thing that could be bad is something with the receiver in the car. Could the antenna have been chewed on by mice or something like that? I suppose it could be, but almost always the sensor is bad. And if you use the tool, you go around each tire, check the sensors, you find out which one is not working, and then you'll know that that a sensor is bad. So the way these sensors work are that they are radio transmitters. They don't typically receive anything from the car. So the car is just in receive mode. So this sends to the computer of the car. It sends the temperature, it sends the tire pressure, and it sends whether the battery is okay. And that's it. And it does it every 30 seconds or so over a specific protocol at a specific frequency. So there are 2 frequencies, 315 megahertz and 415 megahertz. And when you buy an OEM sensor like this one, it is fixed. It is a fixed protocol, fixed frequency device that is made specifically for your car, not programmable. And it has a serial number, a 7-digit hex code that identifies this particular sensor. And the reason that's necessary is the car has to know which sensors are its sensors and which sensors are cars that are next to it. If you can imagine, if you're in a parking lot and you go by another car, you would not want your car to read the tires next to it, right? It would want to read the tires that are on there. So the computer knows what the serial number of the 4 or 5 sensors, there could be one in your trunk in the spare if you have a full-size spare. It knows those, and so that's how it works. The other thing this has is an accelerometer. So when it's sitting all night long when you're not driving, it does not keep transmitting to the car. What it does is it wakes up when it starts to go around, when the tire starts to cycle, and so that saves the battery life. The other thing that could possibly trigger it is if there's a rapid change in pressure, it also will immediately send. It won't wait the 30 seconds. But other than those items, it just sits there and sends all its life every 30 seconds to the car. When the car reads a value that's too low, it puts on the light. Or if it cannot read the sensor, it flashes the light. If you get a new sensor, you could buy an OEM sensor that has a fixed serial number. It will not be the same as the one you have. And then the car will not know that that sensor belongs on your car unless you program the computer of the car to know that serial number. The other thing you can do is you can buy a universal sensor, which is what I'm going to do from, there's lots of companies that make them, but Autel is one. They happen to be the people that have the scanner that I was using earlier. Again, not a sponsor, but they make a good product. So their sensors are both frequencies, 315 and 415 megahertz, and all the protocols. And most importantly, you can change the serial number to any serial number that you would like. So if your car is expecting 1, 2, 3, 4, 5, and you program the new sensor 1, 2, 3, 4, 5, then as far as the car is concerned, the old sensor just started working again. It doesn't know the difference that it's a new sensor. This is the universal reprogrammable sensor that I'm going to use, made by Autel. It does both frequencies, 315 and 433. It also does all the protocols for all cars. It says 99% vehicle coverage. I'm sure that there's some crazy vehicle out there that can't be programmed, but for all intents and purposes, just about every car you can think of, this sensor will work. They make two versions of this sensor. One version has a metal stem with the nut like this one, and another version is just the rubber part. The back electronics part is the same on both, and there's a button you push that you can swap them if you felt like doing so. The distinction on ordering it, there's the part number. There's an M, which stands for the metal stem. So you buy this sensor. It's about $28 a piece, very inexpensive, brand name. It's going to last a while, hopefully. It's got a warranty, and you can program it using the Autel programmer. Aside from the rubber stem and the metal stem designation, there's one other part that they make, which has an adjustable angle. So the stem and the electronics part are fixed in this type sensor, just like this OEM one. But on some tires that have, or some rims that have, I guess, a really severe angle of the sidewall of the rim, you may need to adjust this. So they make one other version that has a screw. You loosen the screw and you can adjust the angle so that it will fit tighter up against the rim, maybe making it easier for the tire to go on. But these are working perfectly fine in my rims, all the normal rims that I've done. This has worked. But just so you're aware, there is one other version that they make. With the programming tool, there are 3 ways that you can program the new sensors. The first way is to read the old sensor. If the battery was still good at all, read the old sensor and then use this and program the new sensor. It remembers it and it transfers it to the new sensor. The second way, if this is completely dead, is you could read the number off the back and type it in and then program the new sensor. The third way that you could do it, if maybe you lost the sensor, somebody stole your tires, I don't know, you had to get new wheels. The third way you could do it is you can hook this up to the car. It's OBD2 port. And what that will do is allow this tool to read the values that are stored in the computer and then transfer them to the new sensors. The thing to keep in mind is it has to be a programmable sensor. You can't use this tool to program OEM sensors because they are not reprogrammable. Now that we know all about the sensor, let's talk about mounting the sensor in the wheel. In the normal world, you would go to a tire shop where they mount tires all day long and have the tire removed, the sensor replaced, the tire put back on, the tire balanced, mounted back on the car, and then reprogrammed. But that would be for best results. And plus, what would be the fun in that? So we're going to go ahead and try to replace, we're going to go ahead and replace the sensor in a tire without a tire machine. Let's get started. All right, so I have the tire set up in the press. I have a 2x4 and a old t-shirt. that I'm going to try to use to maybe make the edges of the 2x4 a little less sharp. Not that I think that that's making any difference, because a tire is a very tough item, but why not? Better safe than sorry. I'm on the side that is opposite of the current sensor in case something goes wrong and I break it off. I'm going to replace it, so I guess it really wouldn't matter, but why do that? And so let's see. Of course I let the air out of the tire, but in case there's any residual air. I could not find my Schrader valve removal tool after 15 minutes, so I had to just stand there and let the air out manually. Well, that didn't work. Let's try again. There you go. So it does not appear that I have damaged the tire, and it actually went a little easier than I thought in the end, but the bead is broken. All right. I don't think there's any way I'm going to do this where I'm not in the way. So just take it out. All right, so it's out. It's all cleaned out. Of course, I didn't bring over the nut. The valve comes with this little pin, and you can put the pin in there and use it to hold while you tighten. Now, it says right on the sensor 4 Newton meters, which is like nothing. So that's, to my guess, that's 4 Newton meters. I don't have a torque wrench that's 4 Newton meters. All right. And that's it. Programmed. Done. So I cut a board on an angle this time to try to make it a little easier. Let's see if that helps any. There you go. Done. Broken bead. Does not appear the tire is any worse for the wear. Okay, I guess out of the way. Trip on it. Turn it around. See if I can break the rest of the bead. I think I have the worst saw stand here holding this thing up. Okay, I'm gonna push it on a little more. That's heavy. Okay. Do it this way so gain access to the Excuse my fingers. So here's the one we just took out, and it is very difficult to see, but 2 of the letters of the ID, which I believe are CC, but it's kind of hard to see, are actually worn away from what appears to be Fix-A-Flat that was sprayed in this, maybe the last tire that was on here. But in any case, if we don't have the ID, then we can't program it and have the car recognize the same one as before. We could read the ID from the car. That would be a way. But I think I said in the beginning of the video that the only thing wrong with this sensor is that the battery's dead. So if I power this up, I should be able to read it and read the ID. So that's what I'm going to do, because why not? So I'm going to peel away the what appears to be silicone caulk. And attach a power supply that is 1.5 volts up to these 2 terminals. Be right back. So I fought with this off camera a bit because the battery went dead, but I was able to get to the 2 terminals and took out the Panasonic batteries. So there's the unit hooked up to a power supply, set to 3 volts, and let's see if we can read the code now. There you go. Voltage okay. I suppose so. You can hook a power supply up to your car, that would be good, as the wheel was spinning around. So it does work. So I suppose if you wanted to, you could try to tear this thing apart and resolder a battery in there. I could not. And plus, are you really going to go through the trouble of changing out a sensor for $28? Battery's probably $5, so I don't think it's worth it. But it does work. So if you did need to get the ID code because it was erased off of the back and you couldn't read it from your car for whatever reason, you had the lower cost unit that doesn't, read the car's registry value, then I suppose it is possible to tear it apart, power it up, and then read the code, and then you got it. So it says right there what the code is. Success. One thing I didn't bring up was the balance of the tire. Because I didn't break the bottom bead, the tire did not rotate. So you would think that if the 2 sensors were similar in weight, that it would not have affected the balance of the tire. In any case, I could always go and get the tires balanced. Let's see if the tire light is out. There you go. No tire light. Success. That's for best results.